Yeah, my name's Martin O'Hanlon. I've worked for the Raspberry Pi Foundation as a sort of employee for about 3.5 years. I work in our learning team, so my job's about delivering learning experiences, predominantly online training for teachers is my bag. Yeah. Prior to that, I worked in industry. I'm a technologist. I'm a computer scientist. You know, I told John if I had to give myself a trade, it would be like computer programmer, right? Something I've done for a really long time. So anyway, what are we going to do? So I want to tell you a little bit about the Raspberry Pi Foundation, because there's lots of things that people don't know about the Raspberry Pi Foundation. Then we'll talk a little bit about what is a Raspberry Pi, and then we'll do some things about like things you can do with a Raspberry Pi, and I'll share some of the things that I've created and some of the things that our community have created, and then we're going to have a go at making something. So we are going to do some simple electronics and some programming, right? So if this is the first time having never programmed a computer, we're going to do some of that today. Yeah. And then I'll sort of finish off with sort of where you can find out more and things like that. Okay.
Martin,
all right.
Just to say, to introduce the two people who've just joined us, Laura Winkley. Laura Winkley is one of the administrators for UKMSA, and by chance, Philip Troth, who's coming on the bottom right-hand corner of my screen, is another member from Amersham Shed. So,
hey.
Yay!
Well,
Hi, Phil.
Hello, Laura. Hello, Philip. Good evening. Hi.
Try that again.
I don't know if you could hear that, but my Alexa just decided to wake up and yeah. So I haven't really started. I'll backtrack. My name's Martin O'Hanlon. I work for the Raspberry Pi Foundation. I have done for quite a while. You know, I'm a computer scientist, right? This is what we're going to do. We're going to talk about a foundation, talk about what a Pi is, and then we're going to make something. Yeah, and we'll do some simple electronics. So, okay, so who are the Raspberry Pi Foundation? So the first thing that a lot of people don't realize is that we're an educational charity, and our mission is to put the power of digital making into the hands of people all over the world. And what that means is we think technology is important, and we also believe that people should be able to harness technology for the purposes that they think is important. So, you know, and we think this is important so that, you know, people can shape an ever-increasing digital world. And one that's really passionate to me is being able to solve problems that matter to them. So we're faced with a problem, go, well, actually, I can use technology in order to be able to find a solution for my needs. And in terms of young people, we also, well, anybody really, we also think it's really important that we're equipped for jobs for the future. So we believe that computing and computer science is for everyone, and we provide training resources for teachers. We run clubs and competitions for young people so that they can get involved in computing, and we support a community of people all over the world. On top of all that, we also make Raspberry Pi computers, and it's an interesting way to fund a charity. Yeah, although that isn't our only funding stream. Okay, so what is a Raspberry Pi? Yeah, we've still got like six people, so we can start like ask questions, right? You know, it's a computer. Not dissimilar to the computer that you could be using, whether you're using a desktop computer, a laptop, or a tablet to join this call. Not dissimilar to that. It's a small computer, it's a low-cost computer, and it's a high-performance computer. So I've got one set up, so I'm just going to show you one. In fact, yeah, what I'm going to do is I'm going to show you a few. So they come in like different flavors, but this is probably the classic Raspberry Pi. That is the Raspberry Pi Model B. A
few years ago, I did have one, a Raspberry Pi Model B.
Yeah.
Sold it, I didn't get on very well.
In the old days, they looked a bit like that.
That's it.
That's a slightly older one. They come in a slightly smaller form factor, or in a really, really small form factor.
So how long? Sorry if I missed the number, but how long has Raspberry Pi been going now?
I didn't say the number. So we launched our first Raspberry Pi computer in 2012.
Right.
The foundation has existed for a little while before that. I can't remember that. I think it might be 2009.
Yeah, that's good enough.
Yeah. So about 9 years, well, 9.5 years. You could point at a group of people and say they are the Raspberry Pi Foundation. Yeah, something like that. Okay, cool. So I've got so many windows open. So just like a computer, you can plug it in and do all the things that you would expect to do with a computer. So you can plug it into a monitor and a keyboard and a mouse, and you can use the internet on it. And you can use it to browse the internet, do presentations, write documents, do your tax return if you felt so inclined. It is a computer. So I've got one sort of connected up. So here is, you can hopefully see my hands. So here is a Raspberry Pi computer. This is a Model B, that kind of, the classic. This is a Raspberry Pi 4, and I've got it connected up to a keyboard and a mouse and a monitor that's just in here. So let's have a look. So we can have a look at that. So it's fine. So this is the Raspberry Pi desktop. So it's got a menu like most computers do, where you can do programming on it. There's things like LibreOffice, like it's an open source, so a free version of Microsoft Office. It's got an internet browser, graphics applications, and all the things you would expect. So I can browse internet, and here is Menshed's website. It is a computer, right? And you can use it as a computer. But however, quite often, while you can plug it into a keyboard and a mouse and all those sorts of things, quite often people don't. And rather than using it as a traditional computer with a keyboard and a mouse and a monitor and all those sorts of things, they put it inside something else. Yeah, so they make other things for it. So I wanted to show you a few things that people have made, right? And I picked these off just I Google searched Raspberry Pi makes, and these were some of the images that came up. So on the left-hand corner, makes stuff. Left-hand side, that's a little arcade machine. That's actually a commercial product. You can actually buy that. So you buy the kit and then you put your own Raspberry Pi. The thing in the middle, which I really like, it's not instantly obvious what it is, but it's a musical instrument that somebody made. And each one of those little hexagonal lights are notes, and they make a sound, and you can compose tunes with it. I really liked that. Took that idea of what a musical instrument could be and made it totally different. There's I actually think that's a weather station, sort of weather station information type frame. But also things like the first one on here, that's they're known as magic mirrors. So people make a mirror, but it's actually got a screen behind it, so you can project information about your day. A robot cat. I mean, everyone likes a robot cat. I can't think of any reason why you wouldn't want a robot cat. Or even something as simple as a flag waving machine. I think this particular one, when I found it, I think it waves every time somebody mentions them on Twitter or something strange like that. But I don't think it matters, it's just, have an idea and kind of create it. And a couple of other things I like the enormous plotter. So it's a hanging plotter, so it's got two ropes, and it pulls the rope and moves the pen about and draws, as you can see pretty impressive pictures. The one in the middle is actually a homemade ROV, so a submarine, remote control vehicle for underwater. And the one on the right hand side might not be immediately obvious what it is, but it's actually a screenshot of a Raspberry Pi booting up. So when it starts up, you see this text come down the screen. It's actually from Stansted Airport. And one of the things that we see with Raspberry Pi computers is they're ever more being used in industrial use cases. So they're actually the check-in boards at Stansted Airport. I wanted to share some of the stuff that I make. So I like old radios. I don't know if anybody else likes old radios. So this is my wife buys old radios, so she can't. Hang on, let me, so you can see it at least. My wife came home with an old radio that looked like this. I mean, it didn't work, and was never going to work. You know, not without huge amounts.
Looks like a portable valve set, is it?
It was a portable valve set. It's got no valves in it anymore though, because I ripped them all out.
Yeah,
so
I guess that.
I took them all out and I put a Raspberry Pi inside it. So I actually made quite a sophisticated sound system out of the box and sort of control system of an old antique radio. I like that idea of sort of making things yourself, but also, you know, I actually really like this.
This is a cardboard box.
It's a cardboard box. It's actually, if you, it's got a speaker that perhaps you can see. It's actually, it's a homemade Alexa. So, you know, the little talking things like that. Yeah.
Very good.
I just like, I like the fact that it doesn't, you know, it's just a box with a button on it.
It doesn't look like an Alexa either.
Yeah.
No, I quite like the idea of that.
Yeah, like a homemade. Yeah. But you can see the Raspberry Pi. You can see the ports on the back, and it's just sort of hidden inside there. I've already kind of shared that I really like video games. So I actually 3D printed all this chassis as well. There's a Raspberry Pi hidden inside here with a little screen on the front of it. And this is actually like a handheld game system.
Yeah, Game Boy.
Game Boy.
Yeah. Modeled very similar on the old, on the original Game Boy.
It looks very much like it, doesn't it?
But just different enough so you can't be accused of patenting.
Yeah.
Do you have your own either 3D printing or CNC sort of system?
Yeah, so I mean, I'm like super fortunate. You know, I have somewhere to come and work and enjoy myself. So this is my 3D printer.
Right.
It's an Ender 3. Interestingly, there's another Raspberry Pi on the wall here. I hadn't thought to show this one, but that Raspberry Pi controls my 3D printer, meaning that I can send files to it and I don't have to mess about with swapping out USB sticks and things like that.
All right.
It's also got a little camera on it because my shed's at the bottom of the garden. It just means I can watch my 3D prints from the comfort of my living room without having to walk down. Yeah, hadn't even thought to show that one, but yeah, there's one there as well. Yeah.
And I've got one here. I don't know if you can. I've got one here. It's an amateur radio. It's
okay. Yeah.
It's a remote server that can connect to the internet, and it will control an amateur radio station.
That sounds brilliant.
One I've been lent to have a play with, but not got round to it yet.
As finding the time is always the most difficult bit.
Yes.
Right, so I suppose the thing I just wanted to kind of leave you with is that, you know, while a Raspberry Pi is a computer, it's a really versatile computer. It's very small. It's low powered. It's cheap as well. Yeah. You know, the typical cost point is about $35, but there are models that are considerably cheaper, right down to $5. So I feel quite comfortable with putting it inside things that perhaps I wouldn't with a significantly more expensive device.
Right.
So yeah, it's a creative device. So right, let's make something. So what I said we would do is I said we would make something. Yeah. So what I want to do today, we're going to just do some simple electronics and we're going to do some programming, because by and large, I find that, you know, those two things are the things that instill fear in a lot of people when they think about kind of computing and how to, you know, use computing in, you know, when you're making something. Yeah. So that's what we're going to do. Before we did that, is there anything we wanted to talk about? Because we're only a small group, we can have a chat.
No, I don't think so. It's and the idea I would like I'm a retired electronics engineer, by the way, so industrial electronics, is that I'd like to introduce electronics in a very basic way to the shed, if at all possible. And I think the fact, if I was to bring up a Pi or an Arduino or something, people would run a mile. I don't know how you find to approach, whether you go into a group like this or into a classroom the approach you take to get people's interest up?
So I think it's about scaffolding that learning experience. And what I mean by scaffolding is by creating something that you can introduce somebody to, i.e. it does something that they have the ability to be able to modify it, right? So you take away a lot of that kind of a lot of that initial fear, or that initial I can't do this, yeah,
right,
by introducing something that's kind of simple. So in fact, what we might do is I might change what we do, and we'll model some of that. So Bob, to your point, we're going to do some very simple electronics, right?
Right.
Yeah. Okay. You know what? Let's have a go. So I got to find the right screen. So this is my this is the Raspberry Pi that I've got set up. So there's a couple of things, and if we kind of look at it, you know, but if you know your way around a computer, you'll notice things like USB ports, and here, and if I can find the way of angling it, that one's an Ethernet cable as well, where you can connect it to, and there's obviously power and screen, and that one's a headphone jack. But the bits that I want to talk about is these set of pins across the top here. These set of pins here. These are known as the GPIO pins, and GPIO stands for General Purpose Input Output. Yeah, it generally means that we can either turn them on, turn them off, or know whether they are on or off. Yeah, and they're general purpose. We can do lots of different things for them. Was
there 16 of those?
There are 40 of those.
Oh wow! So there's 20. So there's 20 of them in pairs, as it were.
Yeah, I mean they're not in pairs. They are. So this is a GPIO label. They've all got they've all got numbers. So some pins, for example, are just provide power. Some are GPIO, some are ground pins, and there are some that have like special functions as well.
Right.
But what we're going to do is, so I'm going to kind of put this label on the GPIO pins just because it tells me which one's which. So we are going to use our first job today is we are going to light up an LED, right? One of the cheapest, most ubiquitously used electronic components. We're going to use an LED. We're going to use a resistor. We're going to use this thing here, which is called a breadboard. Breadboards allow us to create circuits and change them and move things about really easily. And we've also got some cables as well. So this is our plan. What we're going to do is we're going to make a simple circuit. So what we're going to do is we are going to turn programmatically. So we're going to write a program that turns this LED on and off. But before we do that, I'm going to make sure that my circuit works. I'm going to make sure that it actually does something. So I'm going to use my breadboard. And if you can see, it's like full of holes. I don't know how well you can see that.
Yeah.
It's like full of holes. All the holes that are in lines are connected together. So if I was to put something in that hole, it would be connected to any hole that's in that line, right? And that's how we can build a little circuit using this. Because what we're going to do is we're going to use this LED, this resistor, and these wires here to create a circuit to put power through that LED and hopefully turn it on. That's our plan anyway. So I'm going to put this in here. So here we go. Here's that LED. You will notice, interestingly, it's got one leg bigger than the other. Yeah, the one that's bigger than the other. The bigger one is where we put is positive. So if you remember
that's where you want to put some power. Yeah.
That's where we're going to put power, and the other one is where we're going to put. So I'm going to use a resistor because our Raspberry Pi pushes out too much power, and I'm going to blow it up unless I use a resistor. So the job of the resistor is to
moderate the power.
Yeah, sorry, I'm thinking while trying to talk. Yeah. Thank you for that.
Reduce the current.
Reduce the current. Thank you, Bob.
So that's a more technical explanation than moderate.
Yeah. All right. So we're creating a little. Oh, blimey! Why won't that go in there? There we go. All right. So we've created a little circuit. So what we want is power to come through here, through the purple one, through the resistor, through the LED, back out the blue one. Hopefully it'll turn on. So what I'm going to do, just to kind of make sure that works, is I'm going to collect the blue one up to ground. So that the pin that I just plugged that into, I know you can't see it, but that's a ground pin. And the one in the top left-hand corner is 3.3 volts. So that just gives me some power. And my LED turns on. Happy days. right?
At least
Not
your
very
LED works.
Yeah, yeah, and that's what I've proved. I've proved that my LED works, and I'm using my high performance computer as an elaborate battery. Yeah. So let's make that. So let's do something different. All right, what I'm going to do is I'm going to unplug it from the power, and I'm going to plug it into one of these GPIO pins. So these GPIO pins, that general purpose input output, means I can turn it on and off. Yeah. But I can turn it on and off using code, using software, using programming. So that's what we are going to do. We are going to write a small program that turns that LED on and off. Okay, right. I need to change my screen so that you can see what I'm typing.
While you're talking, just changing it, we've got another guy turned up.
Oh, hello.
Another Tony Smith Crallan from Silver's Workshop in Reading, who's one of our well-known UK MSA ambassadors. So.
Excellent. Welcome, Tony. We're going to do some programming.
I've got one of those on my desk already.
Lovely work. What does yours do?
Absolutely nothing. Well, this one is there's a lady present, isn't there? I can't use that word. Broken.
Knackered.
To be fair, Tony, it's me. I think you'll get away with it.
I mean,
I'm not going to say what I was thinking.
I'm not sure if you'll be able to see, but just here, there is the only Raspberry Pi I have ever broken. Right. And it's not actually broken. It's just a bit weird. It's just gone a bit weird. Right. And normally what I use it for is I use it to hold the USB key for my laser cutter. So yeah. They're surprised. Anyway,
that's not much better, is it?
Yeah. Moving on. All right. So what I have done is I've created this little circuit. It's got an LED in it, and I've plugged this LED into. You perhaps can't see it, but I will let you know. It's GPIO pin number 17. Remember that number. It's good. It's a good one to have. All right. So we're gonna write some code. So what you can see on the screen, you can see me. Hi. You can see the Raspberry Pi setup we've just created, and you can see the Raspberry Pi desktop. Right. So this is where I'm going to write some code. Now, the problem is when I do this, I can't see you guys because my screen's not big enough. I've got so many different windows open. But you should be able to see a simple program that says at the top, from GPIO 0 import LED and from time import sleep. Yeah. So I've just written some code to get us started rather than you have to watch me type out a load of stuff. So we are going to write a program using a programming language called Python. And our job here today is to get that LED to turn on for some time and then turn off. All right. That feel?
Yeah.
All right. Brilliant. Okay. So in order to use my LED, now we know it's on pin 17. I need to give it a name, right? And this is because I could have as many LEDs as I wanted, right? But I need a way of referring to that LED. And I could call it anything I want. I could call it Bob, but I'm not, because that'd be a terrible name for an LED. It's a good job for. But so I'm going to call mine Red LED because it's red. Yeah. And I need to tell my red LED what it is. Yeah. Well, that sounds a bit abstract and a bit peculiar, but I need to tell it what it is. But it's an LED, right? And the thing I need to tell it, ignore the args and extensions and blah, blah, blah. Yeah. One of the things I don't like about programming particularly is that all these messages are built for experts and experts don't need them. Yeah. But what I know is that when I create an LED in my program, I need to tell it what pin it's on. Now we know because I plugged it in, it's on pin 17. I'm going to create an LED that's on pin 17. That's it. I've created an LED that I can now use in my program. So what we said we were going to do is we were going to turn it on. Yeah, that was it. Right. We were going to turn it on and then wait for a certain amount of time and then we're going to turn it off again. Let's do that in two separate bits though. So here's my red LED. I want to turn it on. And that's it. That is my program. That program should, let's talk through what this does. These top two lines are telling my program that I want to use two very specific things. I want to be able to use LEDs. Yeah. And this one here, I want to use a thing called sleep. We'll use that in a minute. Yeah. I'm creating my LED and I've told it's on pin 17, and then I'm telling it I want it to turn on, right? So that is our program done. So hopefully when I run it by pressing this big button at the top that says run, our red LED should turn on if I've done my job properly. So let's give that a go. So I'm going to run it and it comes on. Look at that. Yeah. Okay. So, you know, a relatively simple task. Yeah. But what we've proved is that we have proved that we can control this computer and control the outside world using code. Right. Now, what we said we wanted to do is make it turn on and then make it turn off again after a certain amount of time. Would anybody care to guess how I'm going to make this red LED turn off? There are no quick trick questions here.
I was going to say, at this point, should I point out that I programmed in assembler for 7 years?
Yes, please. Yeah, it's all good, mate. Yeah.
As a profession.
Come on, how do we make it go off then?
Red LED off, I suspect. Dot off.
Yeah.
Open and close brackets.
Beautiful. Yeah. We just as an aside point, we open and close brackets because it tells Python that that's a thing called a function. Yeah. A function is something that does something. So I'm going to make it turn on and I'm going to make it turn off. All right. Now I'm going to run this because we're going to see what's going to happen is red LED went off.
Yeah, because there is no time. You've got 2 consecutive instructions with no time interval.
Yes. So there's an interesting thing here about computers. They're super fast, right? So in actual fact, it did turn the red LED on and it turned it off, but it did it so quickly we couldn't see it. Right. So we need to interrupt our program. We need to make our program wait. And in Python, the command to make something wait is called sleep. And we can tell it to sleep for a number of seconds. So I'm going to tell my program to sleep for 3 seconds. So, you know, I'm going to predict that what's going to happen is my red LED is going to turn on. We're going to see it. We're going to be able to count to 3. 1, 2, 3, and then it's going to go off. So let's give it a run. So it comes on. 1, 2, 3, and it goes off. Now, that's all. Hang on. Sorry, I had a bit of a pop then. Can you guys all still hear me?
Yeah.
Oh, brilliant.
Yeah.
Okay, brilliant. All right. So that is kind of like the starting point of any what I would call physical computing program. I'm just going to take a drink.
So how many sort of usable pins have you out of those 40 have you got?
I haven't counted them, but it's quite a lot. But there's an interesting.
Over 20.
Oh yeah, over 20. Yeah. But there's an interesting thing is that a lot of those pins have other functions as well. So one of the things I could do is connect what's called a GPIO extender. Yeah. So I could have more pins.
All right.
And arguably I could keep doing that. Yeah. But there comes a point where actually there starts to be better solutions than single pins to turn single things on and off. Yeah. I think the point I would leave with is that it is very extendable. All right.
Yeah.
Okay, so that's like super simple program. So the other thing that I wanted to do is, so this is an example of an output device. Output, i.e. something has happened externally that we can perceive. What I wanted to do is use an input device as well. So we're going to use a little button. There you can see it's a tiny little button. Yeah. And now our job's going to be to turn our LED on when this button's pressed. Yeah. Right then.
That's going to go into the bread. That's going in the breadboard then.
Yeah. The first thing I'm going to do is I'm going to poke this thing in the breadboard, and I'm going to connect it up as well.
So you need what, a pull up or a pull down resistor?
Well,
whichever way sense you want the switch to go.
Yeah. So Bob has picked up on something. So one of the nice things about the Raspberry Pi is it has internal pull-ups and pull-downs.
All right. Okay.
So I'm going to, and interestingly, unless unless I feel I need to, I don't have to tell it which one I want to use, right? So I'm going to use a pull-up. So I'm going to connect this between pin 18, which is the one opposite the one we did for our LED, and I'm going to and a ground which is next to it.
That's entirely separate from the LED circuit.
Entirely separate from the LED circuit.
Yeah.
All right. So we start to kind of like see patterns when we do programming, right? So we've sort of brushed over this, and we've said from GPIO 0 import LED. GPIO 0 is a software library. It's a piece of software that somebody else has written, yeah, to help us work with GPIO pins. The reason it's called 0 is because it's meant to be what we would describe as zero boilerplate. Right, boilerplate is like having to construct a lot of code or construct a lot of meaning just to get started. Yeah. So interestingly, Bob, one of the things that GPIO 0 does for us is that assumes that we are going to use a pull-up resistor, so I don't have to tell it I'm using one. Yeah. So because I want to use a button, I've already imported LED, so I'm now going to import my button. I need to create a button. So in the same way that I created an LED, I need to create a button. And again, I can call it whatever I want. I'm going to call it, what should we call it? Small black button. No, that's oh yeah, go on, why not? There's a lot of typing. Yeah. And again, I need to tell it it's a button. I need to tell it what pin it's on. I'm pretty sure I put it in 18. I did. Yeah. So this now becomes my pin. The pin that my button's on. And again, in the same way that I can do things with an LED, so for example, turn it on and turn it off, yeah, I can do things with my button. And one of the things I can do with my button is I can tell it to wait for press. So we have old software program, not old as in years, guys. As in not done it for a little while. What do we think this is going to do? So I'm going to press run on this program. What's going to happen?
It's not going to do anything.
It's going to wait for the switch, surely.
Yeah, it's not going to do anything. Yeah, it's going to wait for the switch. Absolutely. Yeah. And then you know, I'm going to press the button. And it's going to turn that LED on. It's going to wait, and then it's going to turn it back off. Yeah. All right, let's give this thing a run. So we're running it, and yeah, it's not done anything. So now we find out if I've plugged it in right and written my code right, because hopefully I'm going to press the button, my LED comes on, and then it waits 3 seconds, and then it goes off. So there's a sort of reason that I like to do these relatively simple activities that show how we work with sort of inputs and outputs, because it starts to open up a much bigger field of opportunities. So you know, I'm using a relatively simple button as an input, but you know, a button as an input is weirdly no different to say an air temperature sensor, yeah, or to I found a few things I thought I'd show. So things like this is a heart rate monitor, a pulse monitor that you put on your finger. And one of the kind of great things about dealing with these sorts of devices through software is that we don't have to worry about how they work. Yeah. So we didn't, when we wrote our program, we told it to turn on or turn off, or told it to wait for a press. We didn't have to worry about actually what are the mechanics of doing that, albeit the mechanics are relatively simple. Yeah, but the same goes for more complex devices. So things like heart rate sensors, or small screens that you stick on the front, or this is a GPS module. I think I found this in my box of things. Yeah, or this is a camera that we can connect. So these are all things that we can connect relatively simply to our Raspberry Pi computer, and using software, the process of interacting with those things becomes much simpler. Yeah.
Can I ask a question on on the wiring? So
yeah.
Is there a degradation of signal or power if, say, you decided to connect So for instance, say I decide to make a R2D2 scarecrow outside, and I want to wire it up so if a kid waves at R2's eye, their head will spin round, so I connect a motor to it. And but I would obviously, I'd want the main part of that system in my house, so I'd run a cable, maybe 3 meters, copper wire. Would that, does it have an impact, or is it all okay? It's not.
I mean, when we're in the sort of range of 3 meters, no, it's not going to make any difference.
No.
Yeah. But you know, with any electrical signal, there will be degradation over time. But it's not going to be in that sort of range, no. But I suppose there's some of the interesting things that I think about when I think about computing is that we take ourselves away from some of those physical limitations. Particularly with things like wireless. Yeah. So actually, we can start to think differently about how we implement solutions. But even way more than that's not going to be a problem. So there's a whole host of like different things that we can connect and we can use as part of our kind of build and to make interesting things. And we like making interesting things. So what I wanted to do is so I made this because I knew I was coming here. So I made a little shed status sign. Yeah. It's got a bit of Vero board on the back of it with some pretty hastily done soldering. Vero board's like permanent breadboard is probably the best way to describe it. So it's a sheet full of holes, but rather than having like little clips where wires sort of friction fit into, you have to solder them in. Yeah, but that's essentially got a button, 3 LEDs, and there's a resistor in there as well. Yeah,
and a bit of laser engraved plywood.
Yes, and and a tiny bit of plywood that I found in my scrap box. Yeah.
But I'm a therapist.
So what I thought we'd do is, as we've got a little time, let's connect this guy up, and we'll see if we can make this thing work.
That's just got 3 wires coming out of it.
It's got 5 wires coming out of it.
All right.
So we've got. So if I show you what we've got a red one, which is the red LED, a yellow one, which is the yellow LED, a green one, which is a green LED, the orange one, which I'm pretty sure is the button. I'll write it down. Yeah, the orange one's the button, and the brown one's the ground.
Right.
Yeah. So I thought we'd connect this up and see if we can make it work. All right, let's go back to one of these. There we go. So we don't need this anymore. Get rid of that. Interestingly, there's a box just behind my head, and the only thing that's in it is breadboards that I don't want to take apart because I think I might need them one day. All right. But anyway, here's our little sign. So what I'm going to do is let's do our LEDs first. So we've got a red one, a yellow one, and a green one. I can't remember what numbers I said I was going to put them. Yeah. So 22. I did notice that the red LED on this, because I made it in a bit of a hurry on Sunday afternoon, is a bit temperamental. So I suspect I've got a loose connection. But what I've done is I've connected each of our LEDs up to one of the pins on the Raspberry Pi. They happen to be 22, 27, and 17. And then what I'm going to do is I'm going to connect the orange one, which is the button, up to 18, which is just behind the green one. I know this is super difficult for you to see. And the brown one is a ground, and that one can go in that ground there. All right. So now we have our little sign, which I was quite pleased with, to be honest. I thought it looked nice. One of the reasons I was quite pleased with it is because I made it in a hurry. I didn't think about spacing, but it just happens to be that when I cut it out, the LED position and the button position were perfect for Vero boards. That was just a happy mistake. I was expected to solder all the components individually. All right. Okay, so let's Which one do we want? Do we want this one? Yeah, we want this one because we want to do some programming again. So this is the point where I can't see you. So, you know, shout up if you want to talk to me. All right. So, yeah, do you know what? I'm going to show you the program. So this is a little program I wrote.
I mean, also sneaked in the room. Phil Taylor from Midsummer Norton.
Hello, Phil. So this is a little program I wrote. So what I'm going to do is I'm going to run it. I'm going to show you what it does, and then we'll talk a little bit about what it does, and then hopefully it starts to kind of make some sense. Right. So let's run it. Hopefully this thing works. I've realised that me sign's too far over. Can you see me sign?
Yes.
Right. Okay. So the green light's on, and the green light says come in. Right. So you know my sort of view was, you know, could put this on the door of the shed, and people know when to come in or not. Right. And then when I press it, it goes to amber. And then when I press it again, this is the one that was a bit temperamental. Yay! Yay. Yeah, it goes to red. Yeah. And then when I press it again, anybody care to guess?
Goes back to green.
It goes back to green, and then we can keep pressing it. And every time we press it, it cycles through each one of those states. All right. Okay. So let's just have a quick look at that. Look at this program that I created. I'm gonna have to make it a tad small. Is that still readable? Is that okay? Or is that too gone too small? Okay. So we're starting to see the sort of same things that we expect, that we saw before. So I'm creating my LEDs now. I've got a red one, a yellow one, and a green one. Yeah, because I've got 3 LEDs. Again, I could call them whatever I wanted. And then you have to trust me on this. The red one is connected to pin 22. The yellow one's connected to 27. The green one's connected to 17. It's worth noting that there's no like number order on these. Yeah, so they're not like one at the top corner. They go 1, 2, 3, 4. They're like virtually random, right? The only order is that each one of these pins relates to a pin on the processor. So it's just however the engineer could route that pin to the processor that's then route. So they, you know, don't expect them to be like nicely ordered. Hence why I've got this little red thing that tells me what numbers they are.
You certainly would need that, wouldn't you?
Yeah, I mean there are loads of references that exist and nice pretty pictures that you can look at on the internet and whatever. But I do quite like the little label.
So where did that come from?
Oh, they cost pence, honestly. Like anybody that sells Raspberry Pis will sell GPIO pin labels. I quite often there's ones you can print out as well, and like literally just on paper, and then just push them over the pins.
I can sell you one for £5, Tony.
There's very little I would buy from you.
I'll sell you one for £4.99.
Oh, there we go.
We get a bidding war
The
going
race to the bottom starts.
So then the first thing my program does is it turns the green LED on, because it kind of feels like actually, you know, when the program starts, right, we should choose which LED should be on or off. So I chose the green one. Yeah. And then as we saw before, we create our button. Our button is on number 18. So now we start to get into actually what makes this program work, right? So there's this thing here that says while true. Now, while true just means do this thing forever, and I do mean forever. So while this program is running, this code or these instructions will continue to run, and and as soon as it gets to the end of them, they'll run again. Yeah, it just means run forever. So we say while true. So forever. What we're going to do is we're going to wait for the button to be pressed. Yeah. And then we get into this idea of if else. Yeah.
Yeah.
So what I'm doing is I'm making a selection, and what I'm saying is, right, if the green LED is lit, i.e. it's on, yeah. So I'll wait for the button to be pressed. The button's now been pressed. Okay. So if the green LED is on, I'm going to turn it off, and I'm going to turn on the yellow one. However, if the green LED is not on, but maybe the yellow one is on, I'm going to turn the yellow one off, and I'm going to turn the red one on. Or if the red LED is on, I'm going to turn it off, and then I'm going and then I'm going to turn the green one back on. Yeah. And then I'm going to wait for the button to be released, because going back to the idea of like computers work really quickly, it'll do this way quicker than I can depress that button. Yeah. So that's what our program does. And I suppose just the kind of point I wanted to leave you with is that I decided that this piece of hardware, so this small sign with 3 LEDs and a button on it, should work that way, i.e. every time I press the button, it should go green, yellow, red. Yeah. If I had made this all with hardware, which would be entirely possible, I could create the electronics to make this thing do that. Yeah. That'd be the only thing it could ever do. But because I've programmed it and because I've used software, I can change that to do whatever I felt was appropriate. So actually, maybe I want it to go the other way around, or maybe I wanted it to start with red. Yeah. In fact, I could do that. So instead of starting with the green LED on, I said, well, you know, the circumstances have changed. I want it to start with the red LED on. And now every time it runs, the red LED will turn on and it will go green, yellow, red. Yeah. Or actually, maybe I decided that that's entirely different. I wanted to show all of the lights on. Yeah. For some particular reason. Yeah. So by using computing and using software, i.e. it's changeable. Yeah. We can create something which is much more flexible. Yeah. And it's also a computer, so you know it doesn't have to be buttons and LEDs. It could be sending things on Twitter. It could be taking pictures of stuff. It could be, you know, sending somebody an email. Who knows? It could be reading the GPS position of, I don't know, whatever. Yeah. All right, super. So that's kind of where I wanted to leave you, other than to say a few things at the end about where you can find out more information. But what do we want to talk about? Is there anything that we would like to talk about? Or is there anything I can help with?
Just one very quick question on the program, if I may.
Sure.
On that little program, do you need the third line, the second else if? Do you need it? Because if you've got through the first two conditions, you don't need, it's not an if statement anymore. You don't need the third if, do you?
No, hang on. This one. No, yeah. You're right. And what I could have done was I could have done. I could have done this.
Yeah.
Yeah. The reason I didn't is it Philip? Philip?
Yeah.
So I could just see the reason I didn't is conceptually people can find that quite difficult to make that leap. Right. Yeah, whereas having individual conditions is a very logical thing to.
Yeah, I wonder if it was a condition of the language you were using.
Oh no. It's just me presenting it in a way which reduces the kind of cognitive load, i.e., the number of things you need to understand.
Right. Thanks.
Yeah. Going back, I say it's probably 7 or 8 years now. I did have an early Pi B. And it was definitely not using C, which is obviously what you're using there for the programming language. And it was just a nightmare. I ended up selling it because it was continually coming up with, you don't have permission for that library. And it really just drove me around the bend. I had the books, I had everything. I spent hours. And in the end, I admit I gave up. I went to something a lot more benign. I've got a couple of Arduinos here, which I'm programming quite happily in C. So, radio use.
Yeah, I mean, so the programming language I was using was Python. Tends to be. Was it? Yeah. It tends to be my sort of go-to language. It's quick to write, easy to run. All those sorts of things tends to be my go-to language. So unless I have something specific I need to do, but yeah, that was Python. I think if it was a long time ago, one of the things that's absolutely improved is software library support.
Yeah. That was probably it. It was, it's got to be about 7 years ago, if not a few more. But yeah. Okay. I need to brush up on Python then.
Something else to learn.
Yeah. No, I've got a son-in-law who is a professional programmer, and he does Python, and well, he does it continually. He's hot on the ball, shall I say? So if I had a problem, he's the man I would go to.
Absolutely. And we should acknowledge that to start programming is hard.
Yeah.
But actually, most of it is just getting over that first hurdle. That I talk about the barrier to kind of entry quite a lot, is in making that first step and getting that first win. Yeah, and it's really important that people get that first win and that first success factor of like, brilliant, I've done something, right? Because it gives you the confidence to try to do something different. Yeah, and which is why one of the reasons I really like to scaffold stuff, so to provide an entry point, to provide an example to that people can change and adapt where they see fit.
I don't think I can share my screen at the moment, can I?
I don't know. I'm not sharing mine. I'm just using my camera at the moment. So.
Yes, you can, Tony.
Okay. I'll just. This is a Raspberry Pi. This is a 3B, I think.
Oh, yeah, running Node.js. Yeah. Okay.
Yeah, but this is the greenhouse. The door is closed. The lights aren't on, and currently the temperature's at 20 degrees. And that's works quite nicely. I've never got around to putting the relay on so that I can turn the LEDs on in the greenhouse. But I've been playing with that for some time, and that one works. But I bought a new this 4B, and it sat on the shelf for a bit because I was doing other things. I came to plug it in, and now it burbles away quietly to itself, but it won't talk to me. It won't display anything. I'm going around the twist trying to fix that one, but I'll stop sharing that now.
I would always start with reformatting the SD card.
I did that.
In which case, I would go for a different SD card, and if that still didn't work, I would then go for power supply. That tends to be my the places that I go first. Yeah.
Yes, because that's one thing. One of the other things I'm looking at the moment is one of the projects I'm involved in is shedding a bus, and we were looking at different ways of presenting information for people as they come around the bus, and that will be another Raspberry Pi 4, and I'm not quite sure what we're going to do with that yet, but it will keep us vaguely amused for several months. Which brings me to one of the questions about heat dissipation. This thing's got, yours didn't have any heat sinks on at all.
No.
Everybody seems to be selling heat sinks for these things. How necessary is it?
Necessary, not. Not. And to be honest, what I would say is that, and unless you're keeping it inside something where it's going to get hot and you're going to use it as in like really processing heavy stuff, right?
You don't need it.
You don't need it.
That's right.
Yeah. None of mine have. And interestingly, one of the things they do is they thermal throttle. So if they get too hot, they'll reduce their processing power to allow themselves to cool down. So it'll never damage itself. It's a very nice way for resellers to make a little bit of money. Yeah, and I say they don't hurt, right? Absolutely not. There is a benefit to having a heatsink.
Well, that one I showed you has been on now for 3-4 months.
Yeah,
it sits in another bedroom.
Yeah,
with an aerial out. It also controls the irrigation on the greenhouse.
I've got an original Raspberry Pi B, so one of these original ones that has been on since the day I received it in July 2022.
That's next year. You don't mean 2022.
July 2012. God, it's hard thinking backwards. I knew it started with a 2. Okay.
An engine or 2, yeah.
Yeah, ends in a 2. All right, so I just wanted to kind of let you know, so in terms of where you can find out more. So raspberrypi.org is a great place to start.
I bought a shed, I took it home, and I erected it. I bought a shed, I took it home, I'd selected it. I bought a shed, I bought a shed, I bought a shed. I followed the instructions, studied all the plans, worked day and night to get it right with blisters on my hands. And when I put the roof on and finished off the floor, I knew inside my heart of hearts I'd be ignorant no more. I heard a no inside my shed, I suspected it. I felt a no inside my shed, I detected it. I was so scared of what he said that I rejected it. He said, forget about the tarot, the I Ching and the runes. Get down your garden centre on a Sunday afternoon. Go past the cafeteria, past all the flower beds. If you're searching for enlightenment, head straight for the sheds. And so we lived inside our shed, and we respected it. I taught him, and he taught me, and we perfected it. And all because I bought a shed.